Dynamic Host Configuration Protocol, or DHCP, became very common in the early and mid 1990s. Prior to that, configuring TCP/IP settings on a large scale for devices was either done manually on each device or by using a script. So DHCP then is the centralized IP configuration that gets delivered to client devices over the network without administrative intervention. So the idea is that we can have a DHCP server in the form of a hardware appliance, and in many cases, DHCP is built into standard routers, including Wi-Fi routers. Or a DHCP server could simply be software that you install and configure within the operating system. Let's take a minute to look at the packet flow with Dynamic Host Configuration Protocol. In step number 1, our client, depicted in the right-hand part of our diagram here, will transmit a broadcast on the local area network to discover DHCP servers. Network broadcasts never cross routers, and so if there is no DHCP server available anywhere on that local area network, the client will not be able to properly partake in DHCP to acquire an IP configuration. You can configure servers or routers on the LAN to forward DHCP discovery broadcast packets in terms of directing it to a DHCP server elsewhere on a different network. One way or another, in step 1, clients discover a DHCP server. Now, existing DHCP clients on the network, when they have to renew their IP config, already know the server's address. Step 2, the DHCP server will then respond to the client with an IP configuration offer. If you've got a DHCP server that services many subnets with different IP address ranges, it will know where the request originated and send the appropriate IP configuration information to the client. Step 3, the client will accept the offer. Depending on how DHCP has been set up by technicians, maybe there's a lease expiration date and time, which means that at a certain percentage of that time having been depleted, the client has to renew the lease with the server. Otherwise, it gets released back to the pool of IP addresses on the DHCP server to then be reassigned to other DHCP clients. Assuming everything works correctly, in step 4, the server will then acknowledge that the client has accepted the IP configuration that it put forth to the client, and then the client is actively talking on the IP network. Pictured on the screen, we have an example of how you would enable DHCP for IPv4 using Ubuntu Desktop. So when you're configuring network settings, you either manually enter IP configuration info or you set it to automatic through DHCP. Then there's the DHCP client side of things. Depending on which specific Linux distribution and which version of that distribution you're using will determine exactly what the file names and locations are of things like configuration files for DHCP clients and binaries that you can use, commands, to manage that DHCP client. On Debian-based Linux distributions, Ubuntu Linux is a good example of that, you can set the DHCP4 option to true within /etc/netplan, and within that netplan directory, there'll be a network configuration file, so open it up, and then after you put that DHCP directive in it, apply it by running sudo netplan apply.